Hey everybody, let's talk about topics 9.3 and 9.4, which are focusing on greenhouse gases and the greenhouse effect. Here we go. So first, what is the greenhouse effect? We're going to kind of go through this step by step. So we've got sunlight, solar radiation, coming and reaching the surface of the planet. Some ultraviolet, or UV, radiation makes it to the surface. The ozone layer does not filter out all UV radiation. And also visible light, Roy G. Biv, red, orange, yellow, green, blue, indigo, violet, the colors of the rainbow. They make it to the surface of the Earth. They go through the atmosphere. Although some of this radiation may get reflected back out to space and not even get to the surface, about a third of it, of that radiation, does get reflected back out to space. So that means the remaining 2/3 of solar radiation are going to come down towards the planet because they're not being reflected back to space. So of that 2/3, some of it will be absorbed by the surfaces on the planet, ocean water, land, which could be soil, asphalt, forests, whatever. So that radiation, or light, whatever you want to call it, is absorbed by the surface of the planet, and it's heating the surfaces. And at the same time, those wavelengths of light in the visible light spectrum and some of that UV radiation also gets converted into into longer wavelength light, which is infrared radiation, or IR. Anytime we are talking about heating the planet, we're talking about infrared radiation, not UV. UV radiation does not affect temperature. So infrared radiation is a longer wavelength of light, and this infrared radiation gets emitted or reflected from the surface of the planet, from the ocean, from the soil, from asphalt. And it's this infrared radiation, like I said, that is responsible for heating the planet. The infrared radiation can be kind of absorbed by the greenhouse gases that are floating in the atmosphere, specifically in the troposphere. Or some of that infrared radiation may escape back out to space, but most of it does get trapped, essentially, by these greenhouse gases. And then these greenhouse gases are trapping heat close to the surface of the planet. So, as the greenhouse gases trap heat, they are warming the planet. And that's the quick breakdown of how the greenhouse effect works. The more greenhouse gases that we have, they're going to absorb more infrared radiation and absorb more, or creating more heat. And so you can think of greenhouse gases as kind of like, I'll use the analogy of blankets. So greenhouse gases, again, are in the atmosphere, specifically in the troposphere. And they surround the whole planet because the atmosphere surrounds the whole planet. And you can think of them like a blanket helping to keep the planet warm. So there are greenhouse gases that occur naturally, no human involvement. And they're keeping the Earth at a comfortable temperature. Greenhouse gases, they keep the Earth, on average around like 57 degrees Fahrenheit, average, around the whole planet. So these greenhouse gases are good for life. If we didn't have any greenhouse gases at all, the planet would be way too cold for us, or for life as we know it to exist. So the greenhouse gases trap some heat, keeping things nice and toasty. As we add additional greenhouse gases to the atmosphere through human activities like burning fossil fuels, we are thickening the size of the blanket that is keeping us warm. Or we're adding more layers to the blanket. And so the more greenhouse gases we have, the more heat is being trapped, and the hotter the planet is getting. And that's essentially what global warming is all about. Warming the planet due to the addition of more and more greenhouse gases into the atmosphere. And this diagram here is showing the same thing, just in a slightly different format than the previous slide. So over there on the left, The sunlight or radiation is going through the atmosphere, and some of it reaches the surface, not all of it. The light that does reach the surface gets converted into that longer wavelength infrared radiation, and that infrared radiation goes back up into the atmosphere, and a lot of that infrared radiation will be trapped by greenhouse gases, which are then essentially keeping the heat in the atmosphere, and that is what is causing the planet to warm. So I keep mentioning these greenhouse gases, so let's talk about what they are. So first, a review question for you. What are the two dominant gases in our atmosphere? I'll give you a second to think about it, and you should definitely know these. The answer to that question is atmospheric nitrogen and atmospheric oxygen, N2 and O2. Nitrogen makes up about 78% of the atmosphere. Oxygen is about 21%. Neither of those are greenhouse gases. They do not trap heat. So we're pushing those off to the side. The other gases in our atmosphere are the variable gases, that their concentrations vary. They're in flux. They're sometimes called trace gases because they occur in trace amounts. So let's go through some of these greenhouse gases that College Board definitely thinks you should know. Here are some examples of greenhouse gases. Water vapor, H2O. Carbon dioxide, CO2. Methane, CH4. Nitrous oxide, N2O. A type of ozone, because there's actually two types of ozone, and I'll talk about that more shortly, or maybe on this slide. And CFCs, or chlorofluorocarbons. CFCs, out of this list of 6 here, are the only ones that are strictly human created. Chlorofluorocarbons, or CFCs, do not exist in nature. They are made by humans. And the proper term for something that is made by humans or caused by humans is anthropogenic. Anthropogenic. So CFCs are anthropogenic. They are created by humans. They do not exist naturally. So these are your major greenhouse gases that you should know about. All of these gases are trapping heat and causing the planet to warm. A way to help you remember the greenhouse gases, I always like to come up with little ways to remember things. You can look at it this way. We call our mothers now. So we, W, water, so that would be water vapor, carbon dioxide, ozone, methane, nitrous oxide. Obviously, CFCs are not on this list, but again, this is just a way to try to help you remember things. And the ozone that is listed here, there's two types of ozone on the planet. There's good ozone and bad ozone. The good ozone is up in the stratosphere, the second layer of the atmosphere. And that good ozone forms the ozone layer, which is a protective layer that blocks out a lot of UV radiation from making it to the surface. UV radiation is what causes, skin cancer and cataracts in the eyes and things like that. So good ozone is up in the stratosphere. The bad ozone that we're talking about here is in the troposphere, because remember, the troposphere is where anything weather-related is happening. This bad ozone in the troposphere, that is a greenhouse gas, this bad ozone is mostly created from burning fossil fuels, especially in cars that have internal combustion engines, which means they run on gas or diesel, so not an electric vehicle. So this bad ozone, or tropospheric ozone, is an air pollutant and a greenhouse gas, which means it traps heat. So anyway, those are some examples of greenhouse gases. I had briefly mentioned this little box here. If we didn't have any greenhouse gases, Earth's temperature would be way, way colder than what we know. on average, it'd be about 0 degrees Fahrenheit if we had no greenhouse gases. And that means if it's an average, there's going to be places that are much colder than 0 degrees Fahrenheit and places that are going to be much warmer. So we do need some greenhouse gases to keep the planet kind of what we're used to. But the problem is that we humans are adding more and more greenhouse gases, making things worse, which basically means these additional greenhouse gases are trapping more and more heat. So the last thing I'm going to mention here in this video is going to be the global warming potential of these gases, although I'm kind of running low on time, so I think I will continue this on another video because I only get 15 minutes for my free video recording. So I'll come back to you in video 2. Ta-ta for now.